Yeah, now let's spend some time in trying to understand this concept of regression. The regression is nothing but, again, I am trying to find a relationship between two variables, but in the form of an equation. Probably saying if x and y are my two variables, let's say sales and price, I am trying to find some relationship x equal to ay plus b, some relationship between x and y in some form. Probably it may come out as x equal to a log y plus b. In some form, there is a y, there is a y which is prices, there is a x which is sales, or probably there could be y1, y2, y3 which are some factors. I know x is dependent on y1, y2, y3. So all we are trying to do when we are doing a regression is establish an equation of this form. Either x equal to ay plus b, or a log y plus b, or some a sin y plus b, some kind of a relationship between x and y, right? And that equation will be used for predicting purposes. Now if I know y, I can find out x, right? If I know my new y, using the past data of x and y, this is how it works. Using the past data of x and y, here using the past data of car sales and car prices, I'll try to derive one equation between car sales and car prices. So car sales equal to something into car prices plus something, right? Again, because we are working from the backwards of the data, here we are not going forward saying first I'll try to find out the price, then 10 times the price plus something 20. I'm not determining my sales like that. Sales is coming from the data. So the reality could be something more or something less. So it does not go as a scientific equation here, right? The dependency between sales and price is more based on the actual relationship that happened in the past, but it has nothing to do with a scientific formula there. I cannot see probably an equation like force equal to mass into acceleration is a scientific formula. Probably in whatever data I talk about, the moment I know what is the acceleration, I will know the force on that same body, because in all conditions that formula will get applied. Whereas I cannot derive such kind of a relationship between my sales and price. There is no scientific relationship. There is no such proof where I can derive using something, but I still need the relationship between the two. So that kind of relationships which we are establishing is what is called as a statistical relationship, or what people call as empirical relationship, right? Probably it may say the sales equal to 3 times the price plus 4.5 something. If you ask me what is the base for it, I say no base. From whatever I have observed from the past data, this equation is looking more reasonable. Always. I can establish in terms of linear, I can establish in terms of anything, log, or probably I can establish in terms of square. Instead of taking y, I take y squared. The variables have to be totally independent. That's the important aspect here. When I am saying y1, y2, y3 are the three variables which are depending on, or which will determine x, I need to make sure that y1, y2, y3 are independent of each other. But in most of the cases, they are interdependent. Now, just for example, if I say the price or the sales of the car is dependent on the price, the engine size, and fuel efficiency. Let's say 3 features I'll talk. Right? I am assuming that these 3 are independent variables. Price, fuel efficiency, and probably the engine size or something, horsepower, whatever it is. Now, it may so happen that they are interdependent. Price may have already incorporated the fuel efficiency as well as horsepower. Right? Probably, logically speaking, when I say A is dependent on B, C, D, my output will be determined. It's like saying this. Okay, my performance is determined by A, B, C's performance if they are independent. But if the hierarchy is, if B and C are reporting to A, if I say my performance is dependent on A's performance, I need not talk about B and C's performance, because B and C's performance is directly reflected in A's performance. So my performance is dependent only on the A's performance. So if these 3 are independent, I'll say there are 3 variables deciding my performance. But otherwise, the 2 are interdependent already on A. So I don't need to consider B and C separately. Or probably if these 3 can be combined into some D, A, B, C can be combined in some form into some D, probably I'll say my performance is dependent only on D. So when I am doing regression, first thing, there are 2-3 points that we have to look at. One, my intention is to establish this equation. Right? Whether I do it on the original data or a squared data or a log data, whatever it is. Right? I am trying to find out the relationship that is existing between the 2 variables. Now, if wherever I am trying to establish a linear relation, I call it as a linear regression. Otherwise, we have multinomial regressions, where I establish a quadratic relation, square, cube, square root. Those kind of relations if I try to establish, let's say saying x squared equal to 3p plus 5. 3p plus something. So that is called as a quadratic relation. So all those kind of relations get in as multinomial regression, which is a polynomial, square, cube, those kind of stuff. But yeah, they go into again advanced models, right? But the most commonly used kind of a model again is a linear regression, where I am trying to establish a relationship between 2 scale variables or 2 or more scale variables, where one is a dependent variable and you have many independent variables, right? So I'll take one example here, and let's try to establish the relationship and try to interpret that relationship. So here I'm taking an example of price. I'll take price as the dependent variable. I want to set the price of a new car that is going to be launched in the market. Right? I'm assuming the price is dependent on probably I'll take the type of the variable, the type of the vehicle, which is either an automobile or a truck. There are 2 types they have identified here. And I'll take engine size, I'll take horsepower of the engine, probably wheelbase, width, length, curb weight, fuel capacity, fuel efficiency. Let's say these are the various factors I think, right? To use the regression and all to a efficient way, what I am saying is I think these are all the factors. These are all the factors that will determine the price of the car. So in this case, what is happening? The price of the car is the dependent variable, and all these are my independent variables. Right? Now, I am assuming they are independent. Now, the system has to check whether they are independent or not. Right? Probably, theoretically, you may say, yeah, probably high horsepower means high engine size. High engine size vehicles will have high horsepower. So, they don't need to be two different independent variables, they are interdependent. Right? So, some kind of interdependency could very well exist between the variables. But initially, what I am starting off is, okay, I want to find the price. So, I am doing a brainstorming session. Each one of you said that these are the factors that will influence the price of the car. Right? No competition factors being talked about, only the manufacturing factors. So, these are the things. So, probably any new car I want to launch into the market, I know all these technical specs. Right? I know all these technical specs. Let's say a new Nano is coming into the market. Probably I would be knowing what is the type of it, what is the engine size for it, what is the width, what is the length, what is the wheel size, blah blah blah. All the technical specs I can know. And if I can establish a relationship between the price and all these factors with a great level of accuracy, then by knowing these factors of the new car, I can decide what would be the price of the car. That is what is regression all about. Getting it? So let's try to apply that concept. So here, let me go to the regression part. I'll say analyze, and before that we require to check whether all our scale variables are normal or not. Right? So better let's quickly go and check that out. At least the fuel efficiency we have already checked. Right? So the remaining things, let's say the engine size, I'll pull out the fuel efficiency now. So I'll look at engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, fuel efficiency. Fuel efficiency we have already looked at. So these things, I am trying to find out the skewness and kurtosis of all these to check whether they are normal or not. Otherwise, I may have to do the required transformations. So probably at least length is directly looking normal. Right? So I don't need to disturb the length. Length is directly normal because skewness and kurtosis are fine. Probably width also I may still get adjusted, more or less fitting in. Whereas the other numbers, or probably once I adjust the other numbers, I may have to see if there is some kind of adjustment that can happen to the length and width also. So because the numbers are not that extremely high in terms of skewness, I'll try to see if directly doing an outlier removal, only one or two outliers lying, and if I can remove those one or two outliers, probably if it can solve my problem, I'll get into the outlier removal part, right? So for that, let me quickly do a box plot. I'm doing a box plot. Instead of fuel efficiency, I'm doing on engine size, horsepower, wheelbase, curb weight, fuel capacity. The remaining two, length and width, I am retaining them. Alright, when I do this analysis, yes, overall it is looking like Viper is on a very high side. Right, as far as some numbers are concerned, looking like Viper is on the very high side. I'm not sure if anything else is showing up as star. So again I would do the select cases where I'll remove one more saying and model not equal to, I should not delete so many records also. So that's where I am very choosy in terms of eliminating of the records. Unless they are very extremely outside, I'm not focusing too much on that. So that's where now when I check out the descriptives, probably some of them are coming in line. But yeah, at least horsepower is still fine, slightly 0.6. Right, probably one or two more outliers looking like, but wheelbase is nothing much different, and fuel capacity is finding some issues. Right, these two are still having some issues, wheelbase and fuel capacity. So it's better now look at once more the box plot. Wheelbase and fuel capacity, the size we can increase. The chart size, but still, yeah, there is looking like some star is here. Yeah, there is some star. F series. Okay, let's see which one is having that. So probably let me reduce it again. Let's say if I'm looking at F series,